Hello dear learners, today I welcome you for the revision of chapter number 5, that is turning effect of forces. Here is the contact information. If you face any difficulty regarding this lesson or related to chapter number 5, you may contact me. The learning outcomes related to this lesson is that you should be able to state what is meant by movement of a force, state the formula of a movement of a force, and relate the movement of a force to everyday examples. State the principle of movement for a body in equilibrium, means in a balanced state. You should be able to explain what is meant by the center of gravity of a body. Describe the relationship between the position of the center of gravity of an object and its stability. So corresponding to these learning outcomes, the content which we are going to cover in this lesson is movement of a force, the topic that is principle of a movement, center of gravity, and stability. So let's move towards the whiteboard. So movement of a force. So first of all, I'm going to draw a free body diagram. So here is the door, free body diagram of a door. This is the part where hinge is connected, or you can say the one part of the door is fixed. So if I apply some force at this end, if I apply some force at this end, what will happen? The door will move in this direction. If I apply force in the opposite direction, the door will move in the one direction. So only two directions are there in which the door can move. One is clockwise direction, another one is counterclockwise, or you can say anti-clockwise direction. Why it is so that sometimes when you apply a force at this end, or you can see the door which is near you, that the handles are at some distance from the pivot point, or you can say from the fixed point. From this point till the point where you apply force by holding the handle of the door, there is some distance, due to which you can open this door or you can close the door. And when you are opening the door or closing the door, you might have either this direction or this direction. And sometimes what happens, if this distance is small, means to say the handle of the door is somewhere near the fixed point, near the hinge, then you might have to apply more force. If I draw a free body diagram in the case where the force is going to apply near the fixed point. So this is the pivot point, or you can say a fixed point. And if I apply now force somewhere here, and if you see, I name it as F2. Now if you see here, the distance from pivot point till the point where I'm applying the force, it is less as compared to this distance. So in this case, I have to apply more force. And in this case, I have to apply less force because the distance is more, so you can easily open the door. And when the distance is less, or you can say the handle, or you are applying the force near the fixed point, then you have to apply more force. So such movements, either in the clockwise direction, either in the counterclockwise direction, these movements are known as turning effect of a force. Turning effect of a force. It is also known as moment of force. Or you can say that this is a torque. So, what is moment of force? What is torque? It is nothing, it is just the product of distance and the force which you are applying. For example, if I state that what is moment of force? Moment of a force. It is the product of a force and a perpendicular distance from pivot point, from a pivot. And you are pretty much clear at this stage when we are doing the revision that what is pivot? This point is a pivot. The fixed point is known as a pivot. This is a pivot point. So I hope so you are clear about the turning effect of force and about the movement of a force. I have given you the example of everyday life that if you open a door or close a door, there are two type of directions, either clockwise direction or counterclockwise direction. We can also say that it is a clockwise movement when there is a clockwise direction, or you can say a counterclockwise movement, that is anti-clockwise movement as well. So now what we are going to do, we are going to discuss the mathematical formula for the movement of a force, or you can say turning effect of a force. For example, if you have the distance, if I say that this distance is 3 meter and the force which you are applying here, it is 2 Newton. Calculate the movement of a force. Movement of a force. What you will do, you will simply apply this formula. Movement of a force, which is denoted by m, is equal to F multiplied by d. D is the distance. As the statement was saying, product, here is the multiplication. The product of force and the perpendicular distance. So you have the force here, that is 2 Newton. You have the distance here, that is 3 meter, and you can calculate that there is a 6 Newton meter moment of a force. And this is the movement of force when you have this force, or you are applying the force, or you are having the handle of a door near to the pivot point. Now if in this case we consider or we assume that this distance is 5 meter, because this distance is more as compared to this d2 distance, and the force which you apply here will be the same. Consider it that you are applying 2 Newton force here. So what will happen if you now calculate the movement? It will be again same, force multiplied by d. And now in this case, force is 2 and distance is 5. How much movement you will get? 10 Newton meter. So it means that 10 Newton meter movement of a force or turning effect of a force is there when you are having more distance. So this is about movement of a force, and its SI unit is Newton meter, as already discussed while covering this topic. So now we are moving towards the next topic, that is principle of movement. We are going to move towards principle of movement. So, in according to the principle, remember that if a body is in equilibrium or in a balanced state, according to the principle of movement, when a body is in equilibrium or in a balanced state, what will happen that the sum of clockwise movement about a pivot will be equal or is equal to the sum of counterclockwise movement, or you can say anti-clockwise movement about a pivot. This is the principle of movement. Here if you see one example, very common example, that if you go in a playground you might see a seesaw. What happens that the pivot point in seesaw is in the middle, and you have 2 points where you can either place some weight or apply some force, or you can sit. One end is here and the other end is on this side. So here what will happen, you will have counterclockwise movement as well as clockwise movement. So this seesaw will be in balanced state or in equilibrium state when the sum of clockwise movement, when means if you calculate the movement of this side, that is clockwise movement. If you calculate the sum of movement of anti-clockwise movement about this pivot, if they are equal, then it will be in balanced state, it will be in equilibrium state. If it is not equal, means that it is not in a balanced state. Now let's see, first we draw a free body diagram and then we will calculate the principle of calculate some movement by applying this principle. So suppose this is the base or the this part of the seesaw, and in the middle somewhere here I have a pivot point on which this seesaw, about which it can move. So from this pivot point till this point, suppose I have distance d1 and a force is applicable at this point, that is suppose F1. The force which is applicable here, the weight which we have placed at this point, it is F1. And on this side we have applied force at this point. This point is not the same from the pivot point as the point F1 is from the pivot. Might be the distance here is little bit less as compared to D2, and it will be, and I name it as D2, and the force which is here, it is F2. So how is it possible that it will be in balanced state? It is only possible that either this force 2, that is F2, is more as compared to this force, or it is only possible that this force is much less as compared to F2. So sometimes such problems are given in the exam, that might be D2 is given to you, D1 is given to you, F1 is given to you, or F2 is given to you. You have to calculate either F1 or F2. One will be given, other you have to calculate. Or it is also possible that both the forces or the loads are given to you, one distance is given to you, you have to calculate the other one. So let's see, we assume some values here that d1 is 2 meter and force at this point is how much? Suppose it is 5 newton, and same force you are applying at the other end. So it will be only in how it will be in balanced state. Now we will apply some principle of movement and we will get the value of d2, and this d2 will indicate that we have to apply this force at this much distance, then it is possible that this seesaw will become in an equilibrium state. So let's see what is principle, apply principle of movement. We said that sum of clockwise movement, or you can say counterclockwise movement, is equal to sum of clockwise. And what is the sum of clockwise movement, counterclockwise movement here? Same formula you have to apply here for the sum of counterclockwise movement. The formula is same, that is for movement of force. F2 multiplied by D2. Why it is so? Because here we have F2 and D2, which is equivalent to sum of clockwise movement, and on the clockwise movement we have F1 and D1. F1 multiplied by D1. You are given the values of these some parameters, that is F2, F1 and D1. F1 is here 5 Newton, D1 is 2 meter, it is in Newton. D2 we have to calculate that at how much distance this force should be so that it can be in equilibrium state. F2 is also 5 Newton. So this is giving you 10 and this is giving you 5 Newton. So D2 is equal to 10 Newton meter over 5 Newton. It gives you 2, and this Newton will cancel with this. D2 is 2 meter. So it is only possible that this seesaw becomes in equilibrium state when D2 is 2 meter. So if we place this D2 somewhere here, if we take this distance, it will not be in equilibrium. So this should be at 2 Newton meter distance if we have to take this much force. So in this way you can calculate the unknown values which is said in the question that you have to calculate, and you can see that how you can apply the principle of movement. This is all about principle of movement, and while calculating, either you have to calculate D2 or F, you must have to be careful regarding units. Suppose now if I take one more example here. First I am going to draw a free body diagram, and pivot is somewhere in the middle. This is not in the middle. Let me move this. Now I hope so it is in the middle. So what is going on, that some force is applicable at this point, and this force is F2, and it is, you can take 3 Newton, and the distance from the pivot point till the point where force is applicable, I say this force is 3 centimeter. And now I apply some force at this point and I name it as F1, and the distance from the pivot till this point is suppose 1.5, or you can say 2 centimeter. So how much force is required to keep it balanced? And now if you see, the unit of movement is Newton meter. Here the centimeter is given. So you have to convert this centimeter into meter. One way is this. And now if you see, we have to calculate force and it is in Newton. So might be possible this centimeter will cancel out. So we will apply principle of movement, that is sum of counterclockwise movement is equal to clockwise movement. So in counterclockwise movement, we have F1 multiplied by D. And in the clockwise movement, F2 multiplied by D. If you put the values or substitute the values which are given here, and this distance is 2 meter, I name it as D1 and it is D2. And F2 is, because both of the distances are not the same, so we have to name them. So to differentiate between them, F2 is 3 Newton and D2 is 3 centimeter. And sorry, it is not in meter, it is also in centimeter, it is in Newton. So 3 into 3 gives me 9, and here I have to do what? F1 is equal to 9 over 2. It is Newton centimeter because Newton multiplied with the centimeter, and here it is centimeter, this will cancel with this centimeter. So now if I divide it, I get F1 is equal to 4.5 Newton. So this force is more. F1 force is 4.5 Newton and this force is more as compared to this force, because here the distance is less as compared to this one. When the distance is less, we have to apply more force so that this object or this system becomes in equilibrium state, and it will be in equilibrium because we are applying the principle of movement. So in this way you can calculate out the uh, values, either it can be force, distance, by using principle of movement. So this is regarding principle of movement, and now we are going to move towards that is center of gravity, or you can say center of mass. So now we are moving towards center of gravity. So center of gravity, or you can say center of mass. The word as says center of mass or the center of gravity is basically the point where the whole weight of a body is acting. Means to say, for example, if I have a scale here, I have this a scale. This is the 0 centimeter mark, and somewhere here it is 50 centimeter mark. So what is the center of this? Obviously its center will be at 25 centimeter. So it means that its whole weight is going to act at 25 centimeter, or the center of gravity of this point is this 25 centimeter. So if I balance this scale on my finger by keeping my finger at this mark 25 centimeter, what will happen? It will be in balanced state. It will not move in this way, it will not move in this way, it will be in balanced state. So if the object is in a balanced state, in this case it means that it is stable also. It is stable also. In other words, as we have defined that center of mass or center of gravity is the point, is a point through which whole weight of an object, whole weight of an object acts on that point or appears on that point is a point through which whole weights of an object acts on it. So if you see, this is the point of center of gravity or center of mass on which whole weight of this object is occurring. Now we can calculate, or we can basically find out how to find the center of mass or center of gravity of different objects. So it's very simple. Remember that if I have, suppose I have a box, let me see in a shape. So I have a box here. I have this box. If I have to find out the center of uh, gravity or center of mass of this box, what I have to do to find that? I will simply draw a line from one corner to another, and then again one more line from another corner and meet at this point. So the point where the intersection is occurring, and this is the point where intersection is occurring, it will be known as center of gravity for this object. Now if I change the shape in this way, that this object is having more height, obviously it is clear cut that its center of mass or center of gravity is going to change. Might be possible if we are increasing the height, not the base, the center of gravity or center of mass will be shifted or rises towards upside. So from another point I will mark a point. So if you see, this is the center of gravity and it is in rises now. This center of gravity is now rises because what happened? I have not changed the base too much. I have only changed the height of the object. And what happened? The center of gravity, it rises. Similarly, you can find out the center of gravity for triangle shape. This is triangle. What I have to do? I have to draw the lines from the corners. Oh, it is not meeting at the correct point. So one corner is this one. Not meeting perfectly. So hope so now it will be in the exact position. No, it's still not in the correct position. So anyhow, in the same way, you can draw from this point. And in the same way, you can draw from the third corner. They are not meeting at the point because corners are not meeting properly with the lines. If I draw up this line and then this line, and then we have to draw the line from somewhere here. So this point is going to the center of gravity or center of mass for this shape. So this is the way that how we can find the center of gravity of different objects with the regular shape. But what we have to do if we have an irregular shape, how we can find the center of gravity or center of mass for those objects? Suppose if I have the shape in this way, this is an irregular shape. Or if I have the shape in this way, this is also an irregular shape. Or you can say if I have the shape in this way, this is also an irregular shape. So to find out the to find out the center of gravity of such objects, what we do, we have to follow a procedure. We have to perform a short experiment, small experiment. And the procedure for this experiment is that first of all you have to make three holes or two holes. It's up to you. Make three holes at the corner. Suppose if I take this shape, I will make one hole at this point, one hole at this point, and the other hole at this point. After making the holes, you have to place this object, place the object or hang the object somewhere. Better is hang the object somewhere by using a nail or whatever you can. So first of all, suppose I hang this object by using this corner, this point, and after that use a plumb line. Use plumb line to see that either the line is going into which direction you have to draw a line. What is plumb line now here? Might be you have seen some of the workers have the plumb line with them. They have the thread. In plumb line you have a thread, and on the one end you have a heavy load connected, and it is used to check either the line is going straight or not. So you have to place the plumb line here, and might be somewhere in this way the line is going on, so draw the line with the pencil. Fourth is draw the line with the pencil. Draw the line with pencil. Now fifth step is now place this point or hang the object from this point, in which you have to repeat this step number 2, but now the corner is going to be changed. This might be, and again place the plumb line, draw a line, some point will be in this way, oh sorry, somewhere here. After that, again repeat step number 2 for this corner, and then use a plumb line. Might be it is crossing somewhere here. So somewhere here you will achieve the center of gravity. So in this way, by applying this procedure, by using such operators, that is plumb line or the pencil, scale, and in an irregular shape, nails and such things you have to require for the procedure which you have to perform this to find out the center of gravity for an object. So this is the way how you can find center of gravity, and we have discussed that center of gravity is basically the center point or a point where whole weight of an object is going to be occur, and that point is known as center of gravity, and we have written it here as well. It is the point. So this is about center of gravity. So now we are moving towards stability. So stability. What is stability? Everyone knows that stability is basically the point or the stable position of an object. For example, if I define stability, it is defined as that a ability or an ability of an object to return to its original position, to return to its original position once it is displaced. For example, if you displace the chair has for example, if you take a chair has four legs, and you place or displace or tilt the chair on on two legs, and after that you leave the chair, what will happen? It will return or move towards somewhere, either in the backward direction or in the forward direction. Why it is moving? Because it is trying to achieve that stability point so that it can get stable. So when it goes to a stable position, means it's in its original position, and that is the stability. So if you see, sometimes what we do in real life, we make such designs either of cars or buildings, you can take, that the base is kept larger as compared to the height. Or you can, yes, one is this, or you can do that you keep center of gravity or center of mass lower, and it is only possible when the base is area or base is larger, so that you can achieve good stability. If the height of the building is more but the base is less, its center of gravity obviously is higher. It is less stable as compared to the building which is having more base. No doubt the height is same. Height is same. So to enhance the stability, we keep 2 points in mind. One is more or larger base area. Second, lower the center of gravity or mass. So this is all about the stability. So I hope so it is clear to you regarding today's lesson, that is related to the revision of chapter number 5, and we have done the revision in detail. Some questions will be given to you, assigned to you for your practice. Thank you, and don't forget to subscribe the channel and hit the like button.